Good day, guys. Welcome to Calcumind, and today we'll be looking at application of ordinary differential equation to mechanical engineering problems. So, ordinary differential equation always find its way into real life solution, into real life problems, whereby one parameter is changing with respect to another. So, we are being tasked to model it to provide a suitable outcome. So now, in respect to ordinary to mechanical engineering problems, ordinary differential equation can be used in simulations. It can be used in chaos theory. It can also be used in environmental studies. So now let's look at a sample problem we are being presented with. It says an object of mass m is allowed to fall from rest in a resting medium if the resistance r is directly proportional to the magnitude of the velocity and the acceleration due to gravity g is constant. Prove that the equation of this motion is given by dv over dt plus k divided by m multiplied by v is equal to g. So firstly, the total force T is equal to F. And now looking at this diagram, we have a resting medium, which is the air, and the ball falls through the medium. Let's assume that the air is resting. So now the ball falls through the medium, creating like a sort of distortion in it. So now from the question, they also said that the resistance is directly proportional to the velocity. So let's write that out. Resistance is directly proportional to the velocity. So now using the variation law, R is equal to kV. So the resistance experienced by this ball as it falls through the medium, R, is constant multiplied by the velocity. So, and we know in real life situation that for any problem, like any falling object, it experiences some sort of resistance, even in a medium or even in water or even through air. It experiences some sort of resistance. So now the force is equal to the force of the ball falling through the medium minus, let's call that F of m, minus R, which is the resistance. So now F of m is the force of the ball falling through the medium, which lets F of m is equal to mass times acceleration. Mass times gravity, rather, because it's falling as a result of gravity. And R is equal to kV. So now we are going to be imputing it into this equation, whereby F is equal to mg minus kV. We can see now from this our equation that F is also equal to ma. So ma is equal to mg minus kV. Noting that a is the acceleration due to gravity. So now taking this parameter over to this side, ma plus kV is equal to mg. And we know that acceleration is basically velocity changing with time. So now acceleration is equal to change in velocity divided by change in time. And we know that this simply means dv over dt. So let's write that out. V over dt. We are now going to be plugging this acceleration directly into this equation. So this is m dv over dt plus kv equal to mg. So now we are going to be dividing this through this whole equation by m. So now this is dividing through by m. So we want dv over dt to stand alone. Dividing through by m, dividing through by m. So this is dv over dt plus kmv is equal to g. So from here now, we have successfully been able to prove that dv over dt plus kmv is equal to g. So let's have a recap. We have a total force whereby the resistance is directly proportional to the velocity. which is the resistance of the board falling through the medium. So now, they say we should obtain an equation for velocity. So if you look at this equation, it's simply relating to the integrating factor problem, whereby dv over dt plus kmv is equals to g. It's looking somehow like the standard integrating factor problem. So now let's write out our integrating factor problem. So this is dv sample equation rather, dv over dt plus p of t multiplied by v is equals to q of t. You can see now that pt is equals to this and qt is equals to this. If you're having problems understanding the integrating factor problem, we did a separate video on integrating factor problem whereby it's a shortcut method. If you go through it, you'll be able to grasp this properly. So now let's jump right into the video. So this y, using y is equal to 1 over I of t integral of I of t q of t dt. So now I of t is basically the exponent raised to power p of t dt. So now if we plug in p of t, and we can see from this equation p of t is k over m. So if we plug it into this equation now and integrate it, we have gotten our I of t. So I of t now go to e integral of k of m dt. So if you work on this now, if you integrate k of m, it will give you e raised to power k of m t. In the formula whereby v is equal to the integral 1 over I of x, sorry, I of t rather, q of x, q of t, I of t dt. So now we'll plug in our values whereby q of t was what? Equal to g. So now we'll then be plugging all the values into the equation. So this vt is equal to 1 over e k mt. Then plug in qt is g e raised to power k m t dt. So now we can see from this equation that g is a constant and we'll be taking it out of the bracket. So vt is equal to, and if you take, like, for example, 1 over a is equal to a minus 1. So let's do the same thing for this. So this is e minus k divided by m multiplied by t. So we are taking our differential, our g, out of the differential. So this is e k m t dt. So now we'll be working on this in the bracket. So this is vt. Vt is equal to e minus k divided by mt. Whereby if you integrate this, it will be k minus e raised to power k over n multiplied by t, all divided by k over m. It's simply, if you have a number like integrating 4x, it will be the same thing as earlier stated in older videos. It's e 4x divided by 4. So that is the idea we are working with. So it will be g multiplied by e k over m t multiplied by k over m plus c. Noting that this all they are separately. So this Vt is equal to mg, whereby this flips, this going to the numerator and this becoming the denominator. So this multiplied by this, all divided by k. So this e raised to power k. You should not forget this also. So we have this. This e minus k m t. Now, this also multiplies by this. So we're having plus c e minus k n. So this Vt is equal to mg over k. From this equation, this cancels out this using the laws of indices, whereby e k over m t minus k over mt. It simply takes that, they simply cancel out. So this will be equal to 0. So this e raised to power 0 plus c e minus k m c. So now this Vt is equal to mg over k plus c e minus k m t. So now, once we have gotten to this point, we should be able to work out the value of c, whereby we're substituting boundary condition such as at v equals to 0, t is equals to 0. Let's work that out. At t equals to 0, v is equal to 0. So now this Vt, this 0 is equal to mgk plus c e minus k m multiplied by 0. So you get the idea now. To get the integrating constant, we are going to be imputing v equals to 0 and t equals to 0. So now this 0 is equal to mgk plus c. This is going to all be 0. So this e raised to power 0, whereby e raised to power 0 is equal to 1. So now c is equal to minus, taking this from this side over to this right hand side, this mgk. So now the full equation for velocity will be Vt is equal to mg over k plus mg over k e minus k m t. So that is the full picture for this equation. You can choose to take out this mg divided by k out of the whole equation. So this Vt is equal to mg over k. Let's write this properly. Let's write it out properly. So this Vt is equal to mg over k. Taking this out, this to be 1 plus e minus k. So if you multiply this by this, it will still give you the same answer for the equation. So thank you for watching the video. Make sure to like, share, and comment. Thank you.